Okay, so what we can actually do as well is we can start to use Venn diagrams to solve, let's say, like real world kind of problem and to try and like organize your thinking as well. Now I'm going to look at this problem, but before I do that, I just want to kind of go through this idea in a little bit more detail. So imagine if we have, let's say, if we look at a body of students that study two subjects. So let's say if we were to say art and science. So these are two subjects that we have, for example, in our own school. And if we were to say that, so we have art and science, and then we have, let's say, art and science. So imagine we have students that do art, students that do science, and then students that do art and science. So if we were to say something like, and then we have, let's say, students who study neither of these. I'll just write this in as well. Okay, so if we try and represent, and let's just put some figures into this as well, okay? So we would have, so we have the universal set, okay, U. So that's the box here. So the universal set really is going to be all of these students, okay? It's just all the students in the school, let's say. We could call the set of students that do art, we'll put these here, so that we call these A. The set A, which is represented by this circle. The students that do science, we call S. And then the intersection here would be the students that do art and science. So imagine if we have, for example, we might have 4 students that do art. Okay, so we have a body of 4. We have 8 students that do science. So let's say they do science only. So these students here, they only do art, they don't do science. These students here, they only do science and they don't do art. And then we could have, for example, 12 students that do art and science, so they do both. And then we might have, for example, 7 students then outside of this, let's say that they don't do either of these, art or biology, so we put them here within the universe of students. So if we think about this then, so let's say, now when we look at, like when we use Venn diagrams, for example, to solve real world problems, we're not necessarily going into all of the individual elements. We're generally interested in the number of elements. And we sometimes call that the cardinal number, and we use this symbol here to represent it. So for example, instead of listing out all of the students, we just have 8 students that do science. We have 4 students that do art, or 4 elements, let's say, within that, which in this case are students. We have 12 students that do art and science, and then we have 7 students that neither do art or science. So when we use, let's say, Venn diagrams to solve these type of real world problems, we generally are looking at the cardinal number, or just the number of students within this, okay? So this is a way that we could represent, let's say, a real world situation using Venn diagrams. So we have group A, we have group S, and then we have like the intersection here in the middle where you have students that do both science and art. So bearing that in mind, let's just have a look at this problem here then. How would we go about tackling this problem? So first of all, let's have a read over it and just see what it's actually asking us to do. So in a class of 30 pupils, and let me change this, 17, so we have 17 study German, 16 study Spanish, and 5 study both German and Spanish. Represent this information on the Venn diagram. So we want to represent this information, okay. So we have 2 subjects, German and Spanish. So what I can do is I can let this set over here be G for German. Okay, and I can use any letter that I want to represent it, but in this case I'm just going to use G, okay? And then we'll use S to represent Spanish. Okay, and that's going to be represented by this circle here. So what it tells us is that so we have 5 students that study both German and Spanish. So think about where we put those 5 students. They would go in here in the intersect. Okay, so G intersect S, that's going to be in here. And we could write it kind of like this. So G intersect S is going to be equal to 5 students. Okay, and that's this space in here. Let's just kind of so this part here. So we would represent this in here within this intersection here. Okay, by 5 students. So they say that there are we have 5 students that study both. Okay, so then when we think about this, like if we want, so use the Venn diagram to write down the number of pupils who study German only, Spanish only, and neither German nor Spanish. So we have to kind of think about this, okay? So if we want to find out the number of students that do Spanish only, or sorry, German only, so we can see here, so we have 17 students that do German. Now, some of those students could do German and study Spanish. But what we can do is we can take away this number here. So if we want to find out the number of students that only study German, we'd have to take the total number of students that take German and take away the students that study German and Spanish, because they would be made up within this number as well. So if you wanted to answer this first part, we would say it's going to be 17 minus 5, which is equal to 12. So what we're saying there is that, so the 17 represents the number of students that study German, but within that group, there's a subset of students that would study German, but they'd also study Spanish as well, and that's represented in this 5. So we have to take those away. So what we're left with then are 12 students that would study Spanish or German, sorry, and we can put this in here. Okay, so that's German only. Okay, so that's the students that study German only. Then if we think about the number of students then that study Spanish only. So Spanish only. So again here we have 16 students that study Spanish. So we have 16. But remember, within that 16, some of them are going to study German as well. So we have to subtract that 5 away from this as well. So subtract 5. And that's equal to 11. So what we can say then is that we have 11 students that study Spanish only. Okay, so Spanish. So 16 minus 5 is equal to 11. And then what we want to think about then are the number of students that study neither German nor Spanish. So what we have to do, we have to think about what do we have to subtract from that. So if we think about so we have in total we have 30. So we want to find out like what's the let's say the students that we have to put out here. So how might we represent that number? So what we'd have to do is we'd have to add up these 3 groups here, 12, 5 and 11, and then we'd have to subtract that from the total number of students. So if we add up, so let's say, so we'd have 30 minus, and then I'll just, okay, so it'll be 30 minus 12, okay, well actually maybe we might do it like this. So first of all, you have to add these up. So it's going to be 12 plus 5 plus 11. So that's equal to 12 and 5 is 17 and 11 is 28. 28. Okay, so this represents the number of students that do German and Spanish and German only, German and Spanish, and then Spanish only. So that will be represented by this number here. So then we have to take that away from the total number of students that we have, let's say, within the group. So it's going to be 30 minus 28, and that's going to be equal to 2. So again, where would we put these then? We're going to put them outside here. 2. Okay. We could say that, so the universe in this case is going to be equal to 30, okay, because that represents the total number of students, let's say, within the group. The number of number of German students is 17, so 17, and the number of Spanish students is 16. Okay, and then if we look in here specifically, these are the students that only do German. These are the students that do German and Spanish, and then these are the students that only do Spanish. These are the number of students that do neither, and then the total number of students that do Spanish and the total number of students that do German. So we can see here that it's a fairly straightforward way to represent fairly complex or fairly complicated information, and we can just represent it like this and look at it at a glance and understand what it's talking about. So again, this is the kind of this is basically what it is we're using Venn diagrams to solve problems, basically, and this is what we mean. So this is just an example of it, and so that's how you go about doing it. So again, pause the video, rewind it, have a look back, and see if there's anything that you're not sure about. Just have a look back on it. So, and let's just okay. So this number here is the answer for part 3. So that's that one. Spanish only, so it's this one here. So 11. That's part 2. And then German only is going to be this one here. And I'll just write down here. So answer to part 1. Okay, so and that's how it's all represented on a Venn diagram. So hopefully that makes sense, and thank you.